This is Signal Hound's Talkin' RF, and today we're talking banner specs. Banner specs are the product specifications that are key to comparing like products, giving you the choice to determine the device that most fits your needs. Frequency range, sweep speed, DANL, bandwidth, and price are all factors when looking at test and measurement equipment. Hello and welcome to Talking RF. Sean here with Justin Crooks, Senior RF Engineer and Hardware Designer for all Signal Hound products. Justin, can you introduce yourself and tell us a little bit about your...
I'm so bad. So I'm Justin Crooks. I'm a Senior Hardware Engineer here at Signal Hound. I've been here for, I guess this is my 18th year. Developed all of our products, that's about it.
Great. And today we're going to talk about banner specs and why they're important and what they are. And Justin, could you give us a little introduction into banner specs?
Banner specs. When I hear banner specs, I think things like IP2, IP3, DANL, phase noise, spurious free dynamic range, all of those things that basically all of them boil down to, am I going to be able to see the signal I'm interested in? And if I see a signal, is it really there or is it some other spectral artifact? With something like IP2, for example, if you've got a whole bunch of cell phones down in the 700 to 800 megahertz range, and you're trying to look at something that's maybe a 1.5 gigahertz GPS signal, and you're seeing a whole bunch of clutter, if you don't have good IP2, those 700 and 800 megahertz are going to mix together at the first nonlinear junction in the system, and you're going to have a whole bunch of garbage at 1.5 gigahertz. So banner specs are really just all about, am I going to be able to see the signal of interest clearly and make good measurements on it without interference?
What are the three most important banner specs for a spectrum analyzer?
So much depends on the application. What are you trying to do? Off the top of my head, IP2, IP3, DANL. But you might have an application where phase noise is super critical. Let's say there's a few 25 kilohertz radio channels, and they're right next to each other. And there's someone that's a tenth of a mile away from you broadcasting, and the signal you're trying to pick up is maybe 2 or 3 miles away. For situations like that, your IP3, of course, is going to be really important. But phase noise might play a role too, because you've got these really strong signals that phase noise skirt could actually cover the signal of interest that's much further away and completely block your ability to receive it.
Where in the world would someone need to take that application? Would it be like field use testing cell phone towers or a military application? Could you kind of expand on where those features would be used in the real world?
Let's say you've got an LTE base station and it's broadcasting this energy, and you need to have your adjacent channel power down by so much. The dynamic range of the instrument becomes very important there, because when you've got this wide modulated signal going into an amplifier or a mixer, it's going to create these third order products that are going to form like this skirt. If your signal's up here, your measurement device could be creating this skirt that you're actually trying to make measurements on. And so something like the SM200, you'd be able to take it out, make that measurement, and because of our IP3 specifications, you'd be able to predict worst case level for those intermodulation products. And if that worst case level was lower than the specification you have to test to, then you'd be comfortable knowing that the SM200 or SM435 would be capable of making that measurement.
When you try to achieve the best possible outcome for balance and performance versus cost, what separates Signal Hound products from other products?
I'm constantly, probably several times a week, looking for new products or new parts that have maybe a slightly lower power, or a slightly higher IP3, a slightly different gain. Sometimes it's not about having more gain. Sometimes it's about having a good noise figure and less gain, because that way you're not impacting the signal levels further down the chain. It takes a lot of time to optimize a signal chain all the way through from RF to bits. Thinking about, where are the potential jamming signals going to be? Where are the potential interferers? What level of harmonics are these customers going to need to measure, and can we meet that? Once I kind of know what parts are available and roughly how much they cost, if it's a $3,000 component that's slightly better than a $5 component, we're going to go with the $5 component and take that half a dB hit on our performance so that we can bring the product to market at a reasonable price. But the trick is finding the part that's almost as good at a fraction of the cost, and design just the best possible system out of those parts.
Well, that is a good overview, I think, of banner specs by Justin, our senior engineer here at Signal Hound. And Signal Hound prides itself on creating unrivaled value in the RF testing measurement technology. And I think you've given us a good introduction into what we can expect from Signal Hound products, and you seem very passionate about it. So I appreciate your time and talking through this stuff. If you have any questions for Justin, or if you want to leave some comments in the comments section below, please feel free to do so, and we'll try to get back to you as soon as possible. Like, follow, and subscribe for more Signal Hound and RF content.